Welcome. This is an introduction to InqVent. InqVent is a mechanical ventilation machine, or simply a ventilator. In this instance, it is a pressure cycled ventilator offering full peak airway pressure. This includes resistive pressure, elastic pressure, and PEEP. It is intended for this COVID-19 emergency. InqVent is configured and monitored by a web-based user interface. Connections can be made from computers, tablets, and smartphones. Connections can be made directly to InqVent or through a local area network. Multiple devices can connect, configure, and monitor InqVent at the same time. Alternatively, one device, say a computer, can connect to many InqVents. With all these methods of connection, many options are available to aid and protect our healthcare professionals. Several scenarios come to mind. A nurse's workstation can be linked to many InqVents. With this situation, a nurse can simultaneously monitor many patients at a glance without having to put on virus protective gear and enter a room. In another scenario, and at the same time, another attendant can attach to one room's InqVent from the door, again not having to don protective gear. A third case, and simultaneously owing to the network ability of InqVent, monitoring can occur across the globe from remote locations. Now, let's jump into the subcomponents that make up InqVent. This is InqVent prototype number 10. Although still in development, full functionality has been achieved. It is now ready for medical evaluation and fine-tuning. Here is a breakdown of the major components. First up is the air supply. This is an off-the-shelf 12-volt air mattress pump. At peak output, it can supply a pressure of about 30 centimeters of water. At the common pressures needed for ventilation are around 10 centimeters of water. It has been derated to increase longevity and to reduce noise. As you might imagine, these pumps are quite loud. In the design of InqVent, this blower has been kept decoupled. The overall design philosophy stresses flexibility. So with other 3D printed adapters, alternative air pumps can be supported. Likewise, in a large emergency hospital scenario, many InqVents could be run off a central air supply via hoses or piping. In a standalone implementation, a lined, sound deadening box could easily be made out of local materials. Next, we have the main InqVent unit. The entire unit measures about 14 centimeters wide by 11 centimeters front to back and 9 centimeters tall. It contains a CPU with supporting Wi-Fi and other electronic circuitry. Starting in version 10, this unit now has 2 improved air valves with their supporting electromechanical servos. The unit connects directly to and fully controls the air pump blower. On the back, the housing has connections for standard airway hosing. We have hoses to and from the patient and have a third exhaust port that can be connected to a third hose to route to an external filter for medical personnel protection. The housing is 3D printed using ABS plastic. It can be printed with about $3 worth of plastic on common printers that support ABS printing in about 20 hours. In final assembly, the unit is fastened together with common drywall screws to permit disassembly for maintenance and cleaning. At the other end of the dual hoses, we find the in unit that will connect to a patient via standard medical equipment. This unit now contains 2 sensors for pressure. With this design, we can maintain accurate relative pressure and near immediate response to patient conditions. It is hopeful this patient-centric positioning of the sensors will permit modes for patient-triggered ventilation, or PTV, including pressure support ventilation, or PSV. This will be studied in the near future. That concludes the hardware side. Now, let's take a look at InqVent's software. Software is clean and simple. Some of this is because it needs to run on all devices such as small smartphones, but mainly it's because I have limited knowledge of what medical personnel need. Ventilator companies seem more diligent about showing how impressive their hardware is rather than how friendly their user interface is. But in InqVent's case, it is just software. And as feedback comes in from the medical industry, features can be easily added, often in minutes, at the most hours. Here we see the basics of InqVent while running common settings of a peak pressure of 10 centimeters of water, PEEP pressure of 2.5 centimeters of water, and at a rate of 12 breaths per minute. In this sequence, we are seeing around 4% deviation from the desired pressure versus time curves displayed in light green. The desired shape of curves can be selected from a list. For development purposes, there are curves for harsh square waves to smooth sine waves, and as illustrated here, a curve pulled from internet ventilator literature is being used. These curves can be created and added easily as medical feedback dictates. The real-time graphing shows a number of cycles that varies depending on the size of the screen being used. In this case, 4 breath cycles are being plotted in a dark green, with the previous 4 cycles plotted in a dim gray. Making modification to settings is possible while running. In this example, I'll change the peak, PEEP, and breaths per minute. The advanced settings will be explained in more detail on the website InqOnThat.com. Once changes are made and the update button is pressed, we can see InqVent is able to readjust calculations and smoothly transition into the new settings, often within the first cycle. Let's summarize. InqVent offers medical professional protection, remote configuration, multiple monitoring scenarios, and small packaging. On top of those that we have discussed, it has several other benefits. InqVent can be built by any maker proficient with 3D printing, mild electronic board population, and Arduino programming. InqVent can be produced in small quantities for around $40 US. This includes all electronics, 3D printing, air pump, and power supply. Obviously, it does not include your laptop, tablets, and smartphones used for displaying the user interface. And finally, InqVent's design will be provided for free. All parts list, 3D printer models, software binaries, assembly instructions, and technical support will be provided free of charge on the website InqOnThat.com. Thank you for watching.